this is the next section. In the previous section, we were practicing writing the reactions and balancing reactions for when we were given the reactants as a chemical formula already. So this is going to add to it by doing one in which now you have to use the nomenclature to write down what the chemical formula is. So this has an extra step to it. So when I look at this, the reaction is between barium hydroxide. So barium has an atomic symbol of Ba, and it's in group 2A, so it's a +2. Hydroxide is a polyatomic ion with a -1, so it's Ba parentheses OH 2, and it tells me that this is a solution, so it's aqueous, plus nitrous acid. So the OUS with acids means it's an ITE ending. So nitrite is NO2. So it's NO2 minus actually. So I'm going to go ahead and just skip straight ahead. It's HNO2. And again, that's aqueous. And at this point, I do this problem very much like I just did the previous ones. So I just have this extra step. Now, if you see this on an exam, I do this as basically all different steps. So the nomenclature part of this is one part of the grade. If you get the nomenclature wrong, I still grade the rest of the question on what you wrote here, not necessarily if it's correct. So you get the partial credit wrong for doing this, but if you take this and let's say that you use just B instead of barium, or you had a 3 here, whatever you have here, I will carry forth when I grade that. Okay, so just because you get this incorrect doesn't mean you miss the rest of the problem. So if you ever see this type of problem, please go ahead and write down something. It could be X and Y really, but write down something so you can get the credit for the rest of the problem. Okay, so this is still a double replacement, so I'm going to do the same thing I did over there. Again, barium is a 2+ charge, NO2 is a -1 charge, so it becomes Ba parentheses NO2 2, and that's aqueous because it's a salt, plus the HOH goes together, so it's H2O, and of course that's a liquid. So now I need to balance it. I've got 1 barium, 1 barium. I'm going to treat this NO2 as an entirety. Okay, so I've got 2 here and only 1 here, so I'll put a 2 there. And then outside of that NO2, I have 2 more oxygens over here, and I only have 1 over here, so I'm going to put a 2 there. Okay, you can still go back and do it by element, but sometimes it's easy to look at this as being a group. Now, and what's also the net ionic, which means I need to write the complete ionic. So I have barium 2+ plus 2 OH minus plus 2 H pluses plus 2 NO2s minus goes to form Ba 2+ plus 2 NO2 minuses plus 2 waters. So my bariums cancel out on either side. The nitrite cancels out on either side, so I'm left with 2 OH minus plus 2 H pluses goes to form 2 waters. Of course, I can take out the 2, so the net ionic is OH minus plus H plus goes to form H2O. Okay. So if it's just a plain acid-base reaction, my net ionic reaction should be OH plus H plus goes to water. We are going to do some in which that's not going to be my net ionic reaction. Very briefly, I want to talk about the fact that it's a polyprotic acid. A polyprotic acid has 2 or more acidic hydrogens. There are 1 of them on this page. This is sulfuric acid. Okay, sulfuric acid, you see the 2 there. All right, so that's more than 1 versus HCl is a monoprotic acid because it's only 1 hydrogen. Other examples would be things like phosphoric acid, which has 3 protons. There's carbonic acid, H2CO3, has 2. There's oxalic acid, H2C2O4. Okay, so there's several polyprotic acids, and so all I'm going to ask you to do at this point is being able to identify whether it's a polyprotic acid or a monoprotic acid. The next topic is acid-base reactions with gas formation. Okay, so there's 3 specific types of those. It is when I see, when I have carbonate as a reactant, and carbonate as a reactant leads to H2CO3 as a product, which means it's not stable as a product, and it goes on to form water plus carbon dioxide. So anytime I see H2CO3 as a product, ding, 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 a little bell should go off that that's not going to be my product. I need to carry it on to 2 more things. Same thing with the SO3. The SO3 becomes H2SO3 as a product. And again, that should set off alarm bells, ding, 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 and that goes on to form water plus sulfur dioxide. The third one is sulfide, and it forms the gas H2S, and this just happens with a double replacement. I have sodium goes to sulfate, hydrogen goes to sulfide, and so I just have to recognize the fact that this one is a gas. Okay, so change colors. So this right here is a gas, and I need to label it as such. And so this is the one reaction in which it's an acid-base reaction, but I do not produce water as my product. It's the only acid base that I do not produce water as a product. Okay? So let's do some examples of this. Oh, whoops, I'll show this first. This is vinegar and baking soda. Okay, so everybody pretty much has seen the experiment where you make a volcano, and this is how you make a volcano go to do the explosive. You put the baking soda in a dish in the bottom, you pour in vinegar when you want to start the eruption, and you get the foamy stuff. And you can add food coloring to this to get colored foam. Okay, so the reaction is the active ingredient vinegar is acetic acid. Sodium bicarbonate, or sodium baking soda is sodium bicarbonate or sodium hydrogen carbonate. And so that goes to form the sodium acetate plus water plus carbon dioxide. And so these two make my foam here. Okay. All right, now to an example. All right, so again, it's going to be double replacement. So the barium is going to go to the nitrate. So I have Ba 2 plus and NO3 minus, so it becomes Ba parentheses NO3 2, and that's aqueous, plus double replacement here is going to be H plus CO3 2 minus, so that's going to be H2CO3. Okay, so when I see this as a product, I go, oops, I'm not done. This goes on to form water plus CO2. So I'm going to change colors so that I don't get this all mixed up. So I have barium carbonate, aqueous, plus nitric acid, aqueous, goes to form barium nitrate, plus water, which is a liquid, plus carbon dioxide needs to be recognized as a gas. Okay, so now I need to balance it. I've got one barium. I talked about I could group these things before, but I can't do that because carbonate CO3 doesn't exist as carbonate over here, so I have to do this individually. I have one carbon. I've got multiple sources of oxygen, so I'm not going to do that yet. I can, however, this NO3 exists as NO3, so it stays together. So I have 2 of those here, so I'll put 2 of those. I now have 2 hydrogens and 2 hydrogens, and outside of this nitrate, I have 3 oxygens, and I have 1 plus 2 is 3 oxygens. So now it's balanced by putting a 2 in front of that nitric acid. To write out the complete ionic, I have barium 2 plus carbonate 2 minus plus 2 H pluses plus 2 NO3 minuses goes to form Ba. Oops, I didn't write that as being aqueous. I forgot. 2 plus 2 NO3 minuses plus water stays together and carbon dioxide stays together. So to go to cancel, barium cancels, nitrate, oops, barium cancels, nitrate cancels, and nitrate cancels. So what I'm left with is CO3, 2 minus, plus 2 H pluses, plus, not plus, goes to form, water, plus CO2. And so now you notice that my net reaction is no longer OH minus and H plus, and this one does not simplify down any further because this coefficient's 1, that coefficient's 2. All right, I'm going to stop here. I'll come back and start with the second reaction on the slide.